All right, number 13. We're given the lateral surface area of a cone of radius r and height h is given by a equals pi times r times the square root of r squared plus h squared. And we want to complete parts A and B. So first it says we're going to find dr/dh for a cone with a lateral surface area of 375 pi. And it says what is the best method to use to find dr/dh. And so this is implicit differentiation. So it says use implicit differentiation to find dr/dh. Differentiate both sides of the equation with respect to a, treating r as a differentiable function of a, and then solve for dr/dh. Okay, so since it says find dr/dh, we're finding the derivative with respect to h. So when it says differentiate both sides with respect to a, that is not right. It says solve the equation for h and then take the derivative with respect to r. Nope, again we're taking the derivative with respect to h. C says use the implicit differentiation, differentiate both sides with respect to h, because that looks good because h is on the bottom, treating r as a differentiable function of h, and then solve dr/dh. So C looks the best. All right, here we're actually going to find a dr/dh. So I've been using the partial derivative. I will do that again because having two r's in the equation means we're going to have to do the product rule. And since we have two r's, that means we're going to have two dr/dh's if we do it the traditional way. And then we'll have to factor, and it's going to make a longer process. So we're going to do it the short way. A equals pi times r times the square root of r squared plus h squared. Now, when we take the derivative, normally we would have a dA/dh. However, they tell us that a is equal to 375. Where was that at? It tells us a is equal to 375 pi. So we're going to plug that in so that when we do the derivative, that constant will zero out. So this, because we don't have a dA/dh, we don't have that, the rate at which the area is changing. So we're going to plug in 375 times pi equals pi times r times the square root of r squared plus h squared. Now, just to kind of simplify some stuff, I'm going to divide out the pi. So if I divide out both sides by pi, okay, it's going to give us 375 equals r times the square root of r squared plus h squared. And then one more thing, we're going to move this 375 over, set this equal to 0. So I'm going to say r times the square root of r squared plus h squared minus 375 equals 0. All right, so now we want to find dr/dh. I do the partial derivative definition, so that's going to be the negative of the partial with respect to h, so whatever's on the bottom, over the partial with respect to r. So this is the formula. Whatever they give you, it's just flipped and you do the partial derivative. All right. So doing the derivative of this function right here, the partial with respect to h means I'm going to treat this as a constant. Put that negative out front, so I'm going to treat r as a constant. And then when we do the derivative of this part, it's inside of the grouping symbol, so we'll have to do the chain rule. So this square root, I'm looking at it as r squared plus h squared raised to the 1/2, so I can do the power rule. So doing the power rule, we're going to multiply by 1/2. And then write down the inside, leave it all alone. Now, we're doing the derivative of h, treating r like a constant when we do the partial derivative. So once I do the derivative of the outside, I got to subtract 1, leave me with a negative 1/2. Then you do the derivative of the inside. Well, you're going to multiply that. So the derivative of r squared is the constant right now, so it's going to be 0. Derivative of h squared is going to give us 2h. Okay. So here's my partial derivative with respect to h. Now we're going to do the derivative with respect to r. That's going to entail the product rule because I have r here and then r inside of here. So product rule 1d2 plus 2d1. And I'll look at this as the first times derivative of the second plus the second times derivative of the first. So r is the first, this square root term is the second, which I'm going to be using this to find that derivative. So 1 is just going to be r. Derivative of the second, we've done that up here, so it's just going to be a 1/2. Leave the inside alone, r squared plus h squared raised to the negative 1/2. Then you do the derivative of the inside. Derivative of r squared is going to be times 2r. And then h is going to be 0, so we don't have anything else. So this is 1d2 plus, we have to do the second. So the second function is this one. I can write it as a square root, it doesn't matter. Square root of r squared plus h squared, since we don't have to do anything to it. So this is 2, and then the derivative of r is just 1. So we're just left with this. So this is 1d2 plus 2, and then d1, derivative of r, since that's the variable we're taking the derivative of, is just 1. If you want to see it, we just multiply by 1, which won't really change anything. All right, so from this part, this is my derivative. I'm going to try to clean this up algebraically, make it look really nice. So anything that's on the bottom, I'm just going to make two fractions, basically. I'm going to have a division bar, and since I have fraction in the top, this 2 is going to be on the bottom, and then the r is going to go to the top. This negative exponent is going to get moved to the bottom, and then I'm going to multiply all this on the top. So in the numerator, we have this negative r times 1 is still r, and then this part's going to go to the bottom times 2h. So this is all going to be on the top. Okay. On the bottom of the numerator, we have a 2 in the denominator. 1/2 power is the same as a square root, but it gets moved to the bottom, so we're looking at a square root of r squared plus h squared. So we got the r, the 1/2, 2 is on the bottom, this negative exponent goes to the bottom, and then times the 2h. So here's my numerator. Denominator, I'm going to do something similar. So I have fraction part in the denominator. We have r over 2. This expression, negative exponent, so it's going to go to the bottom, square root of r squared plus h squared times the 2r, and then plus the square root of r squared plus h squared. Now I want to clean this up because I'm going to have to find the slope, and I don't want all of this junk in there. So here's my derivative, but again, I can clean this up again. So I have a fraction within a fraction, don't like that. So I want to get rid of that. The shorthand method of getting rid of the fraction is I'm going to multiply through by the denominator, the least common denominator in the numerator and denominator. Least common multiple, I would say. So that would be the square root of r squared plus h. That's in the denominator, and then the same thing up here. So I'm going to multiply both sides, and I'm going to simplify some stuff because I can see that these 2's will divide out. I can multiply and get an r squared. So I'm multiplying the top and the bottom by the square root of r squared plus h squared. Doing that because I want to get rid of these denominators. So here's what happened. We're going to use multiplication. It's going to also react with this division. So this part and this part cancel out. 2 divided by 2 is going to cancel out. So in the numerator, I am going to be, so the whole bottom canceled out. This canceled out this, 2 canceled out that. So in the numerator, just one fraction, I just have a negative r times h after everything simplifies. In the denominator, we're going to distribute to both terms. So when I multiply this times this port, it cancels out with division. So this and that cancels out. The 2 divides out the 2 in this part, so we get r times r, which just gives me an r squared. And then when I multiply this times this, I get this whole term squared, which is going to get rid of the square root. And so once the square root is gone, it just leaves me with r squared plus h squared. And then one more thing, I got r squared and r squared, so it's basically a 1r squared plus 1r squared. It's going to give me 2r squared. So we got a negative rh divided by 2r squared plus h squared. So this looks a lot better than what we were just looking at. Here is our derivative. All right, and then once we have our derivative, it says find the derivative when r equals 15 and h equals 20. So this will give us the slope, and we'll just use technology. I'll just plug it all in. Turn this on. I'm going to do alpha y equal enter. Otherwise, you would just make a parentheses and put everything in the top in parentheses, and then divide it by everything in the bottom in parentheses. Here, I'm just going to do a negative because the negative out front, and then r is 15. 15 times 20, it was 300, and then on the bottom, we're going to have 2 times 15 squared, and then plus we'll have 20 squared. All right, so this is solving it and reducing it to lowest terms for us. So after that happens, we get a negative 6 over 17. And so that's the rate at which the radius is changing with respect to height. Negative 6 divided by 17.